think we've got a quorum to go ahead and get started, Doug. So it's a real pleasure to introduce Doug. I was just chatting with him earlier. We get so many different types of talks about LLMs and generative AI, and I'm on a committee right now that's thinking about all the ways in which the world's going to end through generative AI. And, at the same time, we get very little like examples of practical use cases of how people are employing these tools in research. And, Doug is somebody who I happen to sit next to at a meeting that Enrique put together as part of eHail. And we were just chatting, and it was just so fascinating to hear like at a like concrete level, some of the research projects he's been working on through the Department of Emergency Medicine. He is somebody who's a long time kind of, I'm gonna just say it. I mean, he's got this long list of stuff, but he's a hacker, right? And I say that in all the positive ways. He's a programmer. He just gets things done. And right now, I think he's getting his PhD in bioinformatics at Wayne State, while also doing all this wonderful work here in emergency medicine with Prashant and others. So, Doug, it's great to have you here, and we're really excited to kind of talk through some of these examples here at MiCHAMP. So thanks for joining.
Great. No, thanks for the invite. And like you said, I'm a programmer engineer, so let's keep it informal. If you've got questions along the way, please interrupt and ask. Like I said, this is meant to be kind of like a survey of the nuts and bolts. So for those who were wondering, farrago is a confused mixture from the Latin farrago, kind of hash mixed fodder for animals, which I thought was kind of cool because um, we seem to be fodder for the machines right now, or feed for the machines. So, and I'll leave it to those who are curious to figure out if this is a real quote or not, although the title might give it away. So, this is, I hope, kind of the only soapbox, but I do want to kind of orient everybody with this reminder that um, heading into this, that none of these things answer questions. What GPT does, and this is important to what I'll be showing, but also I'd like to remind people, especially those not doing technical, but figuring out what to do with these things, is that GPTs, generative pre-trained transformers, do one thing really well, and they do it really, really well. Given a bunch of words, they figured out what the most probable words to follow are. Now, when you give it a question, that's not the same as an answer. It's a probability. And in fact, when I made this mistake several times, and I finally asked GPT what it thought. It said users may sometimes mistake the generated text as authoritative answers rather than outputs of a probabilistic model. So now that's not to say that GPTs aren't useful. It's just that we have to keep reminding ourselves that they don't answer questions. They will never answer questions. It doesn't matter how much training. They'll always be probabilistic transformers. Having said that, they can be used in systems that do answer questions or do other things well, but as one component. So I'll show you hopefully a few of those components. So this is a project in emergency medicine called ED Visit Necessity. I've been working on since I've been at U of M for about a year now. So the objective is to build a predictive model of emergency department visit necessity by first collecting metrics from previous admissions. And the role that the LLM is going to play in this case is to basically collect data, and to do that will be and this is a word I hate to pronounce because I can never pronounce it, pseudonymizing PHI to maximize language content and consistency. And then the LLM will be extracting metrics from multiple note and test types. And then we'll do full circle. We'll actually have a physician check and see how it did. So what that really means is the first step is the part where it makes it pseudonyms. So we're going to split and merge patient documents by visits, which may involve multiple documents. We'll identify all the potential private information. filter that by name, date, abbreviation, create the pseudonyms, proper names, randomly shift dates. And the guidelines here are that we want to protect that protected information. But we also want to maintain continuity and consistency in the language and the dates that we're going to be using. So the obviously the information is coming from MiCHART from Epic System. The base, I cannot claim I had to do a whole lot of work for this, but the base is the UC San Francisco filter software, which is fantastic. And it's very, very conservative. So that was the first step, is to actually say, okay, on the left here is an actual patient record. And filter says, okay, this is PHI, this is PHI, 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 potential, and blacks it out. So what I did on top of that is to basically write a bunch of software that basically then looked to see what was blacked out and come up with some heuristics and some rules and some filtering that say this is or isn't really protected information. And in this case, most of it wasn't. The one exception in this particular case is the name of the, I believe the nurse in this case that was doing this nurse interview. And in this case, you see a dark green basically means it was PHI, but it's been pseudonymized. So, and in this case, the thing to remember is that to make it consistent, mostly for patient care, is that we're going to maintain gender, we're going to maintain first name, last name, and all that kind of things to make it easier for the language model to actually do the work. But in this case, most of these words were not actually protected information.
So Doug,
Yeah, go
I'm
ahead.
gonna just this is so interesting. This is great. This is the kind of stuff that, definitely want to hear how you went through this process. But I'm gonna ask you to step back because again, I'm so curious as to like how you did this, right? And I'm sure there's folks on this, right? So and maybe it's stuff that other team members were more responsible for, but so I imagine you put in like a typical kind of IRB and kind of the regulatory apparatus or the team did, right? And then where did you do this all within kind of internal systems? Can you tell us a little bit about kind of
Oh,
the
okay. Yeah, sure. No, that's a good question. So this was actually done all in protected systems. So ARMIS 2. So
hmm
all PHI was only processed in HIPAA compliant computing systems.
okay.
So none of it came out.
None of it ever came out.
Nope.
And did
The
you
one
have
the one possible exception, one caveat is in determining names to pseudonymize, I had to determine, is this a first name, a last name, a place name, or other? But in those cases, it was, and we've talked about this before, is basically hiding in plain sight. So what comes out are only a list of names,
right,
and then mixed in is a bunch of random names too.
right.
So if I were to give it to you, you wouldn't know who's a patient, who's where these are, who they are,
Yeah,
what they are, because I'm going to use an LLM to tell me what's the gender. Is
right.
this a place name, a surname, or whatever? So that's the one exception, but there's no context. So
So many of the folks on this call, I think, are going to be kind of very kind of understanding and kind of appreciative of those ways. When you guys went through IRB, did they seem to push back at all because you used the word generative AI and LLM in the application? Or I'm just curious, or did things like you just explained it as thoroughly as you could and things flew through? Or do you remember any of that, or was that other team?
um, I'll be honest, and most of that was done behind the scenes by people that do that kind of thing.
Got it. Okay. Yeah. Yeah.
That's again where I'll hide behind my engineer programmer and say, yeah, that's stuff I don't understand. So I made clear what I was doing and how I was doing it. And to the best of my recollection, we didn't really have any significant pushback. I mean, it's pretty clear that we're staying well within the confines of the protected systems.
Great. As you're going, I know you're going to explain a little bit more about this process. I'm just going to tell you in the chat, Jenna was curious about not only gender, but like, let's say age or race, ethnicity in terms of name, right? Like, did Brahmaji Nalamothu get replaced by Doug Craig or something else? And then another question is just, um, maybe the motivation behind why pseudonymization is so much better, like that hiding in plain sight is better analytically than just blanking out. So that's another question in the chat.
Yeah, so ethnicity was not maintained. There was I generated a random set of names deliberately with broad ethnicity, but the European name may end up being pseudonymized as an Asian name. So, so to address one of the points that maybe I wasn't clear on either too is names are consistent across all of a given patient's CSN, so encounter. So all documents for patient A will always have the same pseudonym for that patient. For any physicians, for any nurses, for anybody in that document set will always have the same pseudonym name. And the reason for that is, again, for consistency with the LLM. So if I'm asking cross-document questions, which are often what I'm doing, that's going to be consistent. And that's the main reason for maintaining for putting in pseudonyms as opposed to just Xing it out. So that language, I'm taking advantage, I'm leveraging a language machine. Taking out proper names is not going to be to my advantage.
Great.
So did I touch on everything I think that you asked?
Perfect. Perfect.
Okay. So with regard to age and to dates, uh, all dates were randomly shifted, but again, a single shift was applied to all documents for a patient set. Therefore, if they received a medication 2 days after admission, that's consistent across all documents. So there's, again, for reasoning purposes, everything is relative. All we've done is just change the fixed point. So back to this. So this is a little more difficult one in the sense that there's a lot more going on here. We've actually got a date, the orange date, and it has been shifted. The doctor's name has been pseudonymized. The patient's name has been pseudonymized. In this case, we actually have something that did not come through. It was decided to be a PHI date that we could not shift. Probably in this case, I think it's because it's actually a treatment date. So this kind of gives you the full spectrum of the things that are being pulled out from what would normally be just hidden from the LLM. I'm peeking over just to see what's going on in chat too. Okay, I'll take a look at that. So here are the types of things that we pulled out. And this had already been predetermined actually before I began the work in the LLM. So descriptive and quantitative things like pain location, associated symptoms. And in this particular problem or set, we were just looking at an initial complaint of chest pain. So pain duration, others in descriptive set, yes, no questions, shortness of breath experience, was the chest x-ray normal, pain throbbing, etc. And I should qualify that we had, so a total of 27 different metrics. So although we did take into account tests, and I'll get into the different test types here, we're only looking, were the results abnormal? So it's not doing any kind of interpretation. It's not trying to read the actual test. It's essentially looking typically at the summary to see, is it an abnormal test? So then so this would be pretty much the full document typed set of 9. So getting into the nuts and bolts, this was actually done with a prompt, and all 27 metrics were pulled out at the same time for each document. So all metrics were listed in the prompt, and then a structure was also given to, and this is using GPT-4o for this description. So what it looks like, for those who are interested in the actual kind of code, the prompt would look like this: chest pain, duration, for example, minutes, hours, days, location of pain. And these are not exhaustive, and they're not meant to be exhaustive, but they're meant to be just directing for the prompt. And then the return, we're using a feature of GPT-4o that essentially allows it to try and make a function call. But what I'm typically using it for, and a lot of people use it for, is basically to force it to return information in a structured way. So rather than in ChatGPT, you ask a question and you get text back. When you use the API, which is what I'm using, you can ask a question. You can say, please give me any instance of associated signs and symptoms. And you can say, please give me back an array, meaning a group is more than one or more of choice associated symptoms such as nausea, vomiting, shortness of breath, and give it to me in this structured way. The nice thing about doing this is that you can, like I said, do in a single pass. You can get 27 different types of things, and you get back a nice, great big structure, and it works quite reliably. So this is some actual results. So what we have, Rutha was our physician that did the review manually. So she went through all the documents for this particular patient, for this particular visit, and she found the associated signs and symptoms included shortness of breath. The language model found shortness of breath, but also found cough, dyspnea, palpitations, and also found shortness of breath spelled out in this case. What this spreadsheet also includes is what note did it find each of these pieces of information. So this is the distillation on the blue line, but these are all actually things it found and in what documents with document IDs, which allows me to go do an audit and see, were these things that it summarized, were they real? Were they on the document? So I can actually go out and pull that out. So this is the raw results of the actual using the LLM to pull in across multiple documents. So you see in this case, we're getting these associated symptoms across provider notes, H&P, consults, and discharge summary. And these are the fun ones. In many of the notes, as the docs will know, you often note explicitly things that are not there. So just because something's mentioned doesn't mean it doesn't exist. So we have a lot of no's. So that's caught not at this level. It actually is noted as a symptom, but at a later filtering level when we actually do the grading. So we'll actually look for things that are prefaced with no because we don't want those. So
Doug,
that gets to, yeah, go ahead.
I interrupt real quick?
Sure.
So there's two questions in the chat. So you said you used ChatGPT 4.0.
Yes.
Okay. Um, and was that in the context of UMGPT or
Yes.
okay, great. And then the second is, when you came up with your prompts, did you do any prompt tuning around that, or was that like, tell us a little bit about that process. That's a great
Well, I
question.
didn't get it right the first time. So,
Yeah.
but yeah, so yeah, it's so much of this is black magic in the sense that it's learning to kind of what's going to work, what's not going to work. But yeah, there were many iterations over these, especially for some of these descriptive types that are, shall we say, redundant or overlapping to see what what's the best way to prompt. So yeah, there was a lot of kind of going back and forth to see what gets the best results. And I don't think I explicitly mentioned this. So the training set included, I think about 87 patients. So I had a review in hand from the physician, and then it's a matter of trying to mimic what the physician is finding and using going through the prompting, tuning the prompting. So I'm getting things that are consistent. And so that was the methodology that we approached. Hopefully that answers. So the previous spreadsheet then gets distilled down to this type of thing where the ID and answer A is the large language model, answer B is the physician, and then we're graded on 8 different ways. So wrong matches there's no match between the two. They are absolutely different, or the language model doesn't provide an answer. Partial matches where the LLM has some of the right answers, meaning some of what the physician said, or there is some intersection. So maybe more for the language model that the physician didn't have, but the physician does have some others. And then superset is another case where the language model found everything that the physician found, and then some. Or physician just didn't find anything, but the language model found something. And then correct, we could have exact matches, or neither provided an answer for a particular thing. So anything that isn't wrong is considered agreement to some degree. So we call that agreement. So that's what the grading was done So overall results were pretty encouraging. So in a test cohort, after everything had been tuned and prompt tuned and trained, we had 57 patients. Uh, Physician took an average of 35 minutes to review about 3.8 documents per person.
Doug, could I,
Yes.
could I, ask you- I'm just curious. We got so many smart people here. Jenna, what's your guess? What's your guess about the grade, the overall grade?
So if I understood the way you're calculating agreement, I could guess you have everything and that still counts as agreement.
So as long as it's not wrong, yeah. So if it's not, if there's no match or the LLM just didn't give any answer. So it gave some partial answer, some superset, or exact match.
So if I said you have shortness of breath, chest pains, leg pain, dizziness, and the doctor said, oh, you have dizziness, that still counts as agreement.
Yeah, that'd be a partial agreement.
I think it's going to be very, very high.
All right. Okay. I wanted to get an informed opinion. I'm very curious to see what you came up with, but all right, good.
So, and you're right, it was pretty good. It was 90% overall agreement. So for descriptive terms, 87%, and for not surprising for yes, no, where it's just a binary, 92%. So if we looked at exact matches, the yes, no was, it's not going to be much different because it's binary, but we still got 42% exact match. So every word in the physician's description was exactly what the language model gave as well. But then we look and saw also that we got 35% of the cases where the LLM got everything the physician got and got more. So the obvious question was the more it got good or bad? So we did a manual review in one case of chest pain associated symptoms. And for 15 patients, there were 31 additional symptoms that the physician didn't find. And all were valid and no were hallucinations. So we our overall conclusion was that obviously we can review a lot faster, but it was encouraging, at least in the small set, that we were finding the LLM was finding more symptoms. They were real symptoms. So in that sense, although we're being generous with what agreement is, one of those generous things is that it's finding more things. And those more things seem to be real things that it's finding. So
Sardar, do you want to ask your question? Because I want to make sure that I understand.
Yeah, I was just asking, like, what was the kind of the distribution or the mean of the number of symptoms per note? These sets that we're
overall,
talking about.
or for these, so oh, for this particular set, I don't know. I'd have to check, go back and see.
Because we were saying
So
like there's a set of symptoms that that was the from clinician, there was a set that was from LLM, and as long as there's any overlap between the two, it's an agreement. So what I guess I'm asking, like, what are the size of these sets approximately?
oh, there's a high variance. I mean, it could be as I mean, I think you saw on the previous slide, it could be just shortness of breath would be the physicians, whereas the LLM may have five symptoms. Um, but yeah, no, that's a good question. I can compute that and figure out. But it could be, it's on the order of, anywhere from one to, a physician probably not more than a half dozen typically, whereas the LLM may find 10 or more. And these are across up to 9 different document types.
Doug, there's a couple of other quick questions, and then Patrick, I'm going to just answer yours. I don't know if Doug would know, but like, there's actually poor agreement in chart reviews in general between humans. That was one of the questions, Doug. Um, and it's one of the reasons why, it makes it very difficult in terms of just quality assessments. But I think that could be a really long question. I think the couple things just to keep it going. Um, Jenna asked. And I think Venk is asking the same thing, like maybe examples of like when it missed. Did it miss kind of on the same types of things, or have you had a chance to look into that? Or Was it just missing more randomly across?
Yeah, on the first point, actually, we've been kind of asking to see if we can get a second review, because I suspected exactly what you said, which would be physician to physician agreement would be probably not much more than what we're finding between the LLM and physician. But without those numbers, I can't make that claim. I can only guess. Things that it missed, I don't think we did any systematic review. Um, I think it falls into the category of a subset where the LLM is finding a subset of what the physician found. So I get those numbers I have in a spreadsheet, but I don't have up in front of me right now. But but we do have those numbers to say physician found ABC and the LLM found A only, and how often it found those things. And I can say in general, one of the most difficult things from these categories were things that were quantitative. So anything where it wasn't just a matter of pulling out some words, but it was like duration of pain. 3 days since, in 3 days. Okay, well, 3 days from is a calculation. So from point of admission, or anything that's relative to another time is always a calculation. It's not something that's just pulled out as a quantitative. So
Okay, that's great. And then Venk, I think, I think he said there were no hallucinations.
of this particular set that we reviewed,
Right.
no.
Yeah. So,
And this method of extracting information in general is a very good way of limiting hallucinations, because you're not really asking for interpretation. You're asking for it to fill in blanks. So
great. How long was the text that you fed into these? Like, just to give us a sense on average, I'm sure that there was quite a bit of variance in that.
yeah, it varied wildly. Some notes, triage notes, may be only a paragraph or two. As you would know, some history and physical documents were running 10 pages or more
Wow. Okay.
on a PDF. Yeah.
All right.
I'll give you another overview of another project. This is kind of at just the proof of concept stage, but it's an interesting another use of the language models. So the objective here was to better understand diagnostic process using follow-up interviews of physicians, of interviews that were recorded during their encounter. So there is actual video of the doctor speaking with the patient that was then transcribed, and then the physician was interviewed afterwards to basically go over and kind of quantitatively and qualitatively assess what they were doing. So the application in this case is to use the LM to perform thematic coding to systematically identify and categorize recurring themes and ideas during the interview's transcript. So in this case, the LLM is being provided a structured thematic coding dictionary. And it's reading the transcript one paragraph at a time, and then prompt the LM to code the paragraph using that dictionary. So then we compare those to actual expert coders to see how it did. So again, this is a very early stage project, but basically trying to do a proof of concept, and then we'll go back later and try and compare and see overall how did it do. So typical dictionary would include things like cognition as a supercategory, and with interruption being a subcategory, with a description, any signal or impulse that causes disruptive activity, cognitive aids, things like that. And then the LM structure results come back similar to what we were doing before, but rather than just pulling out and saying, yes, this is something in there is an interruption, something is a cognitive aid, we actually ask the LLM to tell us where it is in the paragraph, what the text is, so that we can actually highlight it in context, categorize it with the super category and then the subcategory. Sorry, I don't normally talk this long, so my throat's drying out. So here we go. So here's an actual example. So we've got the interviewer saying to the physician as they watch the videotape. The question is here, do you have a cognitive limit on how many patients you can report on before seeing some of them? And the physician responds saying, basically, that he's got a trick of using a sheet of paper to keep track of this. So this is the highlight is actually what the LLM has zeroed in on as one of the categories that we want to code. And in this case, it's saying this is cognition, and it is an instance of cognitive aid where the physician is doing this. And this corresponds roughly with what the human coder agreed. This case, they called that a physical note artifact. But as you can see, subjectively, that's in this instance about the same thing. It's cognitive aid, it's a physical note. Another result, anecdotally, is here we have the interviewing saying, sounds like you're blaming the medication and trying to elicit if this is a bias, instance of bias. And the physician says, yeah, okay, so yeah, so I'm reflecting and say, well, why not? And trying to explaining himself, herself. And again, now we've got cognition and mitigating bias. So again, this is the LLM making an interpretation of the physician's response, categorizing it. And we have the same thing. We have the human coder saying, yep, that was something that I found as well. So
Hey Doug, can you remind us, so when you were saying this, were these like semi-structured interviews? Were they structured, like were there questions that were repeated across these, or were these
that's a
completely
good question.
independent?
I actually don't know. I believe from the transcript I read that this is based on, it seemed to follow more of the flow of the interview, of the video itself.
Okay.
So I'm sure that they had things that they were asking, but I think it was basically being prompted by the situation. So if somebody comes into the room, then they would ask the doctor, well, how did that interruption affect your approach to this? Okay, so now we get into the scary part of the presentation where I'm going to actually try and do a live demo. So this is some work I've been doing for my PhD, but it's also been something I've been applying to some of the work that I'm doing in emergency. So the overarching goal here is to come up with a way to use language models in collaboration with the researcher, or in this case, myself. So it's an open loop question and answer at its base, but we're using, and this is something I had mentioned to Ramaji in conversation, is we're using a RAG system. So there's domain knowledge, and then there's also closed loop experimental context, which provides more RAG information, and quantitative data is fed into the function. So the idea is to use RAG, and for those who aren't familiar, it's retrieval augmented generation. We want to, or I want to, in this design, severely limit the GPT from using its own training information. I want to use it as a language reasoning engine, but I don't want to use it as a database. I don't want to use it as a knowledge source. I want to say, here's information. Please make any reference or inferences using only the information that I'm providing. And in this case, I want to not only use the information that's provided, in this case, primarily from PubMed, but I also want to be able to ask things about my particular experiment. So if I'm doing a quantitative experiment, I'll show you some differential gene expression. I want to be able to say, how does the expression of gene A in my experiment compare to what the literature says I should expect for the context of my experiment? And that's using a functional interface then that's designed to actually go out and get that information and then feed that into the language. The larger picture then for this work I'm doing is also then to integrate this with my mode of thinking, my note-taking system, so that I can feed this information back into a note-taking system and make it much more collaborative in terms of me and the language model working together, providing information, going back and forth with information. So if that sounds kind of grandiose and vague, then I'll actually try and do a demo here and show you what I mean. So hopefully, And hopefully you can see the limerick screen.
We can.
Good.
It's just part of the desktop. I don't know if you want to enlarge it or.
I can enlarge it just a little here if you want. Okay, so this is actually a web application that's running, and it's, I want to show you. Okay, so this is this portion of the demo. We're going to ignore the note taking for the moment. So we can ask a question. So I'll ask a question about what genes are associated with severe asthma. Now, what this is going to do is it's going to ask me how complex, but it's going to go out to its first. It's going to basically parse my question and see what's in my question. It's sensitive to diseases. It's sensitive to gene names. It's sensitive to pathways. That's how I've set it up specifically for that type of experiment. So it's giving me a chance now to go out to PubMed and see if I want to get any more information. I've already previously done a search like this, so it says, do you want to skip it? Or I'll skip it for now because that can be a little time intensive, and it's already populated with some articles. So, and it's now going to also look at the larger question. So it looked for things about asthma, but it's going to say, okay, asthma in the context of genetic markers in that. So again, I've asked the question before, so it's already got some PubMed articles. The key here is it's going to use the RAG, to only use the RAG to answer the question. It's not going to use GPT. So first thing it's doing is basically going out and saying, I found 58 citations. Citations in this case are broken down at the paragraph level. And it's going to try and answer my question based on some paragraphs from these 58 citations. So there'll be a slight pause. So it's going to next step is it's going to basically take each of those paragraphs and say, if I was to answer the question, which of these would be useful for answering the question? So that's a way of basically narrowing down the usefulness or the citations to things that are relevant to my question. So here's actually using the information that's found to answer the question. Again, not from GPT, but from only those articles from PubMed. And I'll neaten it up here and we'll open up the answers. So this is the question I just asked. And if I open up in a web browser, this is actually what came back. So here's my question. So this is its composed answer. This is Limerick's composed answer. And it's citing, and this is kind of the purpose of this approach, is that by using a RAG, basically a private database, I can cite these PubMed articles down to the paragraph level. So unlike GPT, that will give me an answer, and maybe it's hallucinated, maybe it's not. Maybe even cite something that doesn't exist, which has happened to me several times. This will actually give a citation to which I can actually open up. Sorry. Oops.
When you use RAGs, Doug, is the reproducibility concern of, large language models, is that minimized? I mean, if you put that same question in 10 times, would it come back in the same order, the same type of structure?
There's variability, but I did in preparation actually ask the same question twice, so I guess we can actually take a look and see if that's the case. But so here's the two. Oops, I'm sorry, I'll set them side by side. So looks like we've got the same genes. Some variability. So yeah, you're going to get variability just because you're asking the language model to compose an answer. Yeah, but the sources are consistent, so you should get, in fact, we can actually look at the final references that it used and see how close they are. So we got 4 there. Whoops. Sorry. And looks like they're a little different. Yeah. Chatular. So the interesting thing about this, so again, everybody's concerned is hallucination. So one interesting thing that can be done with this approach, which I tried, was to inject uh, fake facts, alternative facts into the RAG. So in my case, I said that the normal treatment, the recommended treatment for cataracts is replacement of the eye by a pig eye. And I put that in my database, and then I asked questions. And I got answers that were basically relying on that as authoritative information. It was easily disproved by the GPT. It obviously knows that's not the case. If you enter that into ChatGPT, it will not tell you that you need to replace your eye. But the RAG is basically forcing it to use only the information it's been given and use that as the authoritative information. So it's a two-edged sword, because if you start feeding in fake information, you're going to get out fake information. But the upside is that you get basically cited information. You can actually go out and find where it found the information that it's supporting its answer. So
Patrick Brady had a great question about, are you calling the PubMed API on the back end to gather the sources, or?
yeah, so PubMed has well, it's a couple different approaches. So the search is being done just like you would a normal search through the API, and then retrieving articles is being done through another API, which will actually give you full text back. So I see in the chat somebody's asking about GPT-01. Yes, they do information like that, and that'll get into my next demo if I have a few minutes left here. So again, I'm sorry, this is going to be pretty I started to say sketchy. I know it's not sketchy, but it's fairly broad strokes about what this is doing and how it's doing it. But hopefully the takeaway is that this is an instance where we're using a private collection of information, which is being compiled by the researcher, saying, I'm interested in this, please collect these articles. And now let's answer some questions based on what I've collected. And that's kind of a common thing for me. If I'm working on a particular project, I want to get some authoritative reviews and some authoritative articles, and then use that as the basis for going further into the information. So now I'll show the next step that I mentioned in the overarching scheme is to actually integrate that with, let me get rid of this one here. I'm sorry, the screen's a bit busy. So this is, although it looks the same, it's a bit different. This now is integrating the same type of software now with my note-taking. I don't know if anybody uses Obsidian. I used to use Evernote. I've kind of shifted over to Obsidian as a note-taking application. I like it because it keeps all of its notes in plain text, which is very nice. So let's, since somebody asked about O1, how about we do something like that? So we'll do a simple question. So this comes from actually the test set that O1 bragged about, the Google Proof question set. So these are questions that can't really be answered by doing a simple search. They involve steps, multiple steps. So this is a question from that data set. So we'll grab that and we'll put it into our document. And this is just a note-taking document. So I'm going to make a copy there. And then I will, I'll prompt Limerick to take a look at it.
Okay.
So this is it speaking as it's going.
Creating a plan.
Okay, so it's going to create a plan just below these documents. So that's a document that it just created. And these are the steps that it's decided that it needs to perform to actually answer that question. And this is a question about genes. So it's going to go through each of those steps, and these are the answers. So it's gone through the first step, gone through the second step, and here's its reply. Here's what it's answering. So we're just kind of following it as it goes down the checklist. So this is very similar to what O1 does. And I'll highlight how it's different in a minute or so when it gets to the answer. So this is a gene experiment. And I'm sorry, I went through that kind of fast, but it's a multiple choice question. So it's going through the steps it thinks it needs to answer that multiple choice question. And then we'll see if it gets to the answer or not.
Finished.
Okay. So it came to the conclusion that, in summary, while errors are the effect of the gene mapping, it's likely due to a double crossover event. And it's one of the choices, I think, in our original question is double crossover event. And in this problem set, the first answer is the correct answer. It doesn't know that, but I do. So this is basically mimicking in a similar way to how GPT-01 works. It's a simple chain of thought. So it's basically breaking the problem down into multiple steps, going out, getting the information, doing each step, but then taking into account what it's found so far in its answer, and then at the end, basically using all that information to answer the question. So what is somewhat novel in the way I've implemented it is I can now go out to, and since this is my note-taking application, I can go out to the document and I can say, well, I'm not sure that this step was correct, so I'm going to uncheck that and then ask it to
Redoing last plan.
redo it, and it's going to actually go out and recalculate this. Now, I had the option, I didn't do it, but I could also have added my own notes to this and augmented what it found with what I know about the problem as added information for calculating.
Finished.
So, and if I don't like something, I think that's not right, or I don't really want to take into account that, I have the option of just basically Xing it out and saying, no, I don't want to use that. Please redo it. And if I really want to be invasive in terms of what it's doing, I can ask it to redo it.
Redoing last plan.
And I can ask it to
Give me a moment.
I can ask it to stop when it's finished with whatever it's doing.
So paused.
Now it's paused. So that gives me a chance to review what it's done, make any comments, make any changes, make any additions to what it's doing, or even stop it right there, and we'll come back to that later.
Resuming plan.
Or then I can just have it go off. So again, this is kind of a really quick overview of some of the work that I've been doing. This is rather limited right now. It's most of the work. This is hot off the presses. Was integrating with the note-taking application. Now, the next steps for me are to try and
Finished.
Thank you. Is to try and integrate it more deeply with how it's reasoning. So the steps that I want it to take and to iterate through and create some feedback so I can actually improve its way of reasoning with some case-based reasoning and integrating it with some of the semantic graphs that I'm using to keep track of what the best way to answer certain questions are, and then link it with the other software that I showed before that allows it to go out and use custom functions. So it can actually search Wikipedia or other things or use computational methods to actually integrate. So anyway, sorry if that sounds really hand wavy, but I just wanted to give kind of a quick overview and still leave some time for questions.
Thanks, Doug. Sadar here. Brahmaji had to leave to get to the airport and asked me to finish the Q&A.
Yeah, yeah, he told me you would.
Please put your questions in the chat while we're waiting. I was just wondering, so this is very interesting, but do you validate this? How do you validate this? Or do you need to validate it?
Yeah, so if you mean by validation, how do I know that the question, how do I know that these things are actually...
How do you even measure how good it is? I mean, do you have a metric? Do we have a metric?
Well, narrowly in this case, I'm using these questions from the question from the Google Proof Q&A. I actually have real questions, real answers. So, so I can, in that sense, validate just like GPT 1.0 does. My interesting experience so far has been that the couple times I've gotten different answers, meaning not the multiple choice answer, I'm having flashbacks to my college undergrad and thinking my multiple choice answer was right. And interestingly, the problem set actually includes comments by reviewers saying why they think the answer is right or wrong. And very often the GPT is saying, yeah, that's not a great answer. This is a better answer. And it's mirroring what some of the reviewers are saying. So I find that encouraging and also discouraging in the sense that I can't objectively grade this. It's very difficult.
Don't see any questions in the chat yet. I can keep going asking my own questions. So if I understand it correctly, in the previous use case, the one with PubMed, so you ask a question and then it composes a question to submit to the API, to PubMed API, and get a response. Did I understand it correctly?
Oh, with the first demo?
Yes.
No. So it's composing, so you're asking a question and it's checking to see what sources it may need, giving you the option of doing a PubMed search, and then using that information to answer. So it's never, in fact, it's forbidden through prompt engineering from using its own knowledge to answer the question. So it's explicitly being told, do not only use the information that's been available in the RAG and in the corpus of information that it's accumulated. So, and that's to answer to go back to your first question, that's the validation step in the sense that when it gives me an answer, it's giving me a traceable answer. I can actually go out to a PubMed publication, to the paragraph that it's using to answer the question that I've given it. So in that sense, I can say, yes, they got it right.
Okay. Any other questions? You can also raise your hand to unmute and ask your questions. Ramaji touched on uncertainty a little bit. So in your first use case, if I understand it correctly, you're giving the notes associated with an entire encounter, or are you doing your analysis at a note by note basis? Are you giving it just a note and saying, does this note contain this symptom, or what symptoms does it contain? Or are you giving it the entire encounter for a patient and then asking?
It kind of the opposite. So I'm giving a one note at a time and asking you to pull all 27 of the metrics in from that note, if any of them are available. And then likewise giving it the next note, next available note. So for one patient, there may only be a nurse and an ED note, and then they don't get admitted. For an admitted patient, there's going to be additional notes. So, but that same process is done for every document available for the patient. And then there's a reconciliation across all those at the end to say, let's aggregate all the symptoms across all available documents to get the full set. Does that answer your question?
Yeah, but at the time when you're analyzing the notes, when you're analyzing the second note, there's no awareness of the first note. So
No.
you're doing it individually? Okay.
It is done. Yep, it's done. Yep, de novo.
How about doing it like, have you tried doing it like with the awareness of the previous note? And
That's a good question. There's no reason you couldn't. What would be the advantage? I mean, in the sense, I guess you could, in the sense, prime the GPT or prime the program to know what's potentially there. So as a physician, if you're looking at the at OneNote, if you review the consult note or the initial admission note, would that make you look for something in the next note, in the consult note, or something like that, I guess? And how is that useful? So, but I think you could. I'm not
thinking
sure.
maybe,
Yeah, go ahead.
maybe in the case of symptoms, it's less likely to provide value. But if you're thinking about a complex disease process, the information that would lead you to say, yes, this patient has, let's say, heart failure or not,
Mhm.
maybe spread out through multiple nodes. So if you look at an individual, you may
Oh, yeah,
just
yeah,
see
yeah,
it
yeah,
as
yeah.
part of the picture.
Yeah, no, yeah, exactly. Yeah, I think it's a bit of a different use case, but I certainly agree with you that, yeah, if you're trying to put together a larger picture and come to some larger conclusion where you're filling in pieces that may be scattered across multiple notes, I think that, yes, you certainly want to have some kind of ongoing cumulative structure, data structure, or whatever, or list that you could then add in and confirm, disconfirm as more information comes in. So it would probably also be useful to have a chronology. Because I mean, that's exactly what you're doing, right? You're ordering a test. Okay, confirmed, disconfirmed. You're having a consult. More information, not helpful is helpful. So yeah. So we're not really doing that in this case. We're only looking for basically pieces of information that we will then ultimately feed into a model, and that model will be used to try and detect patterns for whether that admission was needed or not. Yeah.
Yeah. Now we have 2 minutes, but I see a question from Patrick. Patrick, maybe you can ask it quickly.
Yeah, sounds
that
good.
would be
Thanks very
last.
much. Doug, thanks for this presentation. I think you and I are meeting with a few folks next week, so I'm looking forward to that. Are you using the GPT toolkit via Azure for the API calls for 4.0?
Yeah.
Okay. All right. And I assume was that part of the requirement when going through the IRB to use that?
I believe so. Yeah. Yeah.
Okay. Thanks.
Cool, awesome. I don't see any other questions. Well, thank you so much, Doc. This was very intriguing presentation. I think some of the applications were made me think of potential new projects, and I may be reaching
Well,
out
good.
to you.
Then I've served my purpose. Yeah. And like I said,
Yes,
I
you
know there was a
absolutely
lot
did.
left out, and it seemed maybe hand wavy at times, but hopefully it at least made raise some ideas and maybe some potential things that you could do. So good.
Yeah, absolutely. Thanks, everyone, and we'll see you next time.
Okay. Thanks.
Bye-bye.